Hi, Stuart here. Today we're going to talk about Elastic version 7 as used by developers in .NET Core 3.1. This is going to be the first of a series of YouTube videos. As always, all the code can be found on my GitHub site. Before we get started, as this is the first video, I wanted to sort of talk about what Elastic is, and then we'll talk about some use cases. And then as we go along, we'll have some more advanced use cases in future videos. So Elastic is the technology which is a sophisticated indexing and search engine that's based on the Apache Lucene open source project. And Lucene was developed with an initial set of algorithms that essentially asked the question, how could we do searching much more efficiently than the traditional index crawling of initially SQL, but then considering other NoSQL options as well? And if we could build an engine that prioritized searching above everything else, we could get back very, very fast results, even if the data sets got very, very large. And as Lucene, the algorithm set, evolved over time, they started throwing in sharding and partitioning and multi-server implementations and things that would help not only make the indexing engine more durable, more highly available and fault tolerant, but also more scalable. So people ask, well, the word elastic is used a lot when people are talking about search engines, most of which are based on Lucene. So Elastic is the commercial implementation of Apache Lucene with support, curation, documentation, additional features, things like that. It's worth pointing out that curation is, in fact, an important aspect. And that is, when they do releases of Elastic, they've done extensive testing for compatibility, for vulnerabilities, for durability, and so on. So when you are asking yourself the question, do I want to just use Apache Lucene and have it all DIY where I'm responsible for everything? Or do I want to spend some money and get all these other good things? For most commercial organizations, the answer is it makes sense to buy products and services from Elastic, the company. So version 7 is their latest and, in my opinion, the very best version of Elastic that I've yet seen. I'm sure 8, whenever it comes out, will be fantastic too. But going from 6 to 7, I couldn't help but notice that 7 is dramatically better, mostly in ways that are very obvious. It has better support for more scenarios. It has lots of proprietary and very clever index optimizations that make for very fast searches. It supports a wide variety of data types and the matching libraries that go with it. And in this set of videos, I'm a .NET developer. I love C#, so they're all going to be built on .NET Core 3.1 LTS. And we're going to use 2 library packages, one called NEST, which we're going to show you in this video, which is a set of high-level abstractions over searching in general, and then Elasticsearch.net, which gives you access to the low-level APIs. If you're a developer and you're consuming indexes that are made on your behalf by, say, a data group or whatever, I would say more than 80% of the time, NEST is not only a lot easier to understand and use, and will make you more productive by letting you do the most common scenarios quickly, but it's plenty performant because underneath the covers, it's doing lots of clever and optimized things. But if there are certain use cases, especially if you're actually building and curating indexes from code, there's every reason to suspect that using the low-level Elasticsearch APIs will be very handy, and in future videos, we're going to show you some of those scenarios. The other thing is, as a developer, I love anything that runs in Docker because it means that I can very quickly get up to speed and start exploring. So I knew a fair amount about Lucene before I started playing with Elastic. And I knew something about Elastic Code because I had worked with using it to capture telemetry using the triplet called ELK, which is Elastic, Logstash, and Kibana, the dashboarding tool. But I hadn't thought about using it in an application context other than I'd used Lucene for a couple of projects. And I decided that if I'm going to build things for customers and they're going to have enterprise expectations, that I'd probably be better off doing them in Elastic. Here's what we're going to demo. Okay. First thing I'm going to assume is you've got Docker for Windows Desktop 10 installed and running. I put together this little bash script that you can use, or you can use your own. It's important that if you're using a different container image than the one that's in my script, that you also take the time to read the release notes that go with it to see if the Docker run command changes. So I have used this bash script to start Elasticsearch running in my Dockers for Windows 10. And there you go. You can see that BElastic is running on port 9200. So the main class that's got the examples in it is called Search Worker, and you'll find it in the Worker subdirectory. There's lots of other cool boilerplate in here that you can ignore if you want. For example, things around parsing out the runtime arguments on the command line and things like that. It doesn't matter because we're mostly going to focus on the regions that show us how to do things. So we are going to focus on using the NEST library. And again, we saw the link to the NEST NuGet package. Again, if you're using a different version of the NuGet than I am, make sure that you read the release notes and look and see if there are any breaking changes. So let's look at this. Let's look at this a piece at a time. Okay, here we are in our demo code. Couple things to point out. All the code we're going to be showing off in this demo is here in the Search Worker class. You can find lots of other cool code other places in the program, but this is where the Elastic goodness is. Also, you can see that we are using our NEST library up at the top. First things first, we need to make a new client. And to do that, we're going to create a new instance of some Elastic settings. And we're basically going to do that by supplying the URI and a default index name. The default index name, by the way, is optional, but very handy. And then we're going to create our client object by newing up the Elastic client and passing in the settings. So next thing we need to do is to create a search index. A search index is where the search data lives. And if you're using Elastic as sort of an Elastic database, an index is where we're going to put things. So I created a little helper function called indexCreate if missing. And you'll notice that NEST understands the C# type system. And so in this case, I'm saying I want to create an instance of my POCO class person. So let's go look at our POCO class person, and then we'll look at indexCreate if missing. So here's our POCO class person. You can see it has an ID, a first name, a last name, an email, and a phone. And it also has a little helper method that lets us make random people. And I should credit Jacob Firm, who came up with this amazing library called Faker to produce real-world, realistic data that's fake. And so you can read more about it, and I'll post a link to the Faker NuGet, or you can just look up the information on my GitHub. The next thing is to look at my little extension method. because I found that it was sort of interesting to have the logic for creating an index if it didn't already exist, and for specifying that if it found an index, it wanted to drop the index. So one of the things that's challenging for developers who programmed with the Elastic libraries before is that a lot of APIs change from version 6 to version 7. Up to version 6, they'd kind of be evolutionary. What they did in version 7 was they said, okay, if we were doing this today from scratch, how would we organize the various objects and object collections and methods to be more useful for someone learning it for the first time? And so there's a little trade-off there, and that is if you've been using Elastic Library version 6 against Elastic Engine version 6, and you switch to 7, you're going to have to learn some new things. If you're coming at it new for the first time, then you're going to find this extremely easy to use. So on line 43, we say, okay, does the index we're trying to create exist or not? And if it does exist and we want to drop any existing indexes, then we call delete first. If it doesn't exist, then we call indexes create and we give it an index name, and then we give it essentially function mapping to, again, the type aware POCO class of person and tell it to auto map. Now, this is the easiest, laziest way to create an index because we're asking the engine and its APIs to do all the work for us. And believe it or not, it works amazing amounts of the time. But if you want more control over your indexes, well, you're going to have to watch a future video or go look it up yourself because we're not going to cover it here. So we're just taking our POCO class, indexing all 5 fields, and telling the index creator we want to auto map them. Now that we've got a connection object and its index, and we spit out the output to the console, we're going to have to populate it with data. So here's the region that creates the data we want. And again, we're getting some arguments from the command line, like how many things we want to create and so on. And we're using our POCO class of person, and it knows how to create random people. And so if we click on create data and we go look at it, you can see that it's a very simple method that loops through, makes a random person, and then calls client.indexDocument on our type aware person POCO, passing in the instance of person that we made. And since we set it up to auto map in the background, giving it the type, it will happily index the fields that are in the person class for this person. Okay, once we've done that, here's the fun part. Let's do some searching. So we have a search term. We're going to use that over and over again. We have a result set. We're going to use that over and over again. And notice that here again, it's type aware. So I search responsive person. So the first search we're going to do is your basic wildcard search. I'm going to build a very familiar looking wildcard expression. In this case, search text, by the way, is lowercase s, lowercase t. And then I'm going to do underbar client.search of models.person, so it knows. And I'm going to supply the basic paging parameters. So starting from page 0, and we're going to take up to size number of rows, pretty typical paging interface for most APIs, very easy to use. And I'm going to specify the index name. Parenthetically, this is what style, the fluent style of building expressions, and it can leverage link in its expression building. So all of our searches are going to have the from, the size, the index, and the query. But what changes inside the query are the query builder terms we use. And if we use the fluent syntax, we can apply them to be link expressions and all kinds of fun things. One happy note is I won't talk about boost in this video, but when in doubt, either omit it or set it to 1. So in this case, we're saying define our first name and we want and the last name, and we want the value to be our wildcard expression. And that works because this is a wildcard search term. Okay, now we want to do a range search. So again, client search of model person, from, size, index, and query are the same, but you'll notice we're using a different query building expression. In this case, we're using the range expression. So we're saying greater than or equal to 1 and less than or equal to 9. And when that, for all intents and purposes, compiles, you'll get the appropriate range expression that works against our search engine. We can also do a value search. And in this time, the query builder expression is term. And in this case, the term expression takes two arguments. One is the column I want to search on, and the other is the value I want to search on, which is a literal. And in this case, this is the moral equivalent of selecting from a relational database by its primary key with the primary value. So this is how you could get a specific record out. But you can use it for searching all kinds of terms. Just remember that results are always going to be in an IEnumerable of whatever we asked for. In this case, IEnumerable of models.person. And we can do phrase searching too. And in this case, we're using the builder object of match phrase on the email field. And we're saying, look, match anything in that field that contains the search term. And in this case, we're looking for nomail.org. Happy note on boilerplate. You'll notice I'm wrapping all these in a little timer so that I can show you the results on the way out. So let's run this, watch it execute, and then you can download the code and play with it yourself. Okay, up to the top we go. So I told it I wanted it to generate 100 records, and you can see that that Jacob's Faker library does a really great job of making realistic data. By the way, this is totally worth doing because not only is it appreciated by business users, but it's appreciated by long-suffering QAs and devs too, who are tired of seeing random data generated in ways that aren't meaningful or that don't follow the correct business convention. So here you can see that a phone number looks like a phone number, and there's a whole bunch of different variations, and that first names and last names look like first names and last names. This is a good thing. Many thanks again to Jacob Firm for coming up with this library. Okay, so here are our various searches. So search number 1 is the wildcard search, and you can see that if you look at the 5 rows that we got back, that all of them in their first name or their last name have an S and T together. By the way, we did a case-insensitive search. By default, it is in fact case-sensitive. So be aware of that when you're building expressions. In the second search, we asked for a range query, and quite obediently, since ID is the primary key, so to speak, we got rows 1 through 9. Then we said, look, I want you to only search the ID field where the value is equal to 9, and lo and behold, we only get our number 9 record back. A contains search on a word, notice no wildcards here, and it matched the very first 10 rows since we said our page size is 10 rows, but it really would have matched all 100 since they're all at nomail.org. Couple of things I want to point out. One is it's well worth exploring your way through the API and see all the different kinds of expression builders that they built into the query object. There's more than just the one showed here. The ones shown here are a good start on 4 common use cases, but it's a very rich and easy to use syntax. And the second thing I want you to notice is how easy it is to create indexes, put data into indexes, and then query indexes using NEST. NEST is a great set of convenience methods. In future videos, we'll cover advanced scenarios, and we'll dive down into the Elasticsearch API itself to show you some tricks that would be hard to do using NEST. But again, I strongly urge you to try to use NEST first. As it is the 80% use case for most programming problems. Thanks for your kind attention.